From this lecture, we will start the study of magnetostatics. Now, the force on an electric charge does not only depend on where it is located, it also depends on how fast it is moving. So, every point in space, as far as electromagnetics is concerned, is characterized by two vector quantities which determine the force on any charge. So, the first component we have already seen, the electric force component Fe, it is characterized by electric field at that point into the magnitude of the charge. And the another component called the magnetic force, it is having a peculiar directional property, and it also depends on the velocity of the charge. That is how fast this charge is moving. So at any particular point in space, both the direction of this force as well as the magnitude of this force depends on the direction of the motion of the particle, that is how fast it is moving. Also, at every instant this force is always perpendicular or at right angle to a fixed direction in space. That is, let us say this is this charge moving with velocity v. So this force, magnetic force, is going to be perpendicular to a specific direction at every instant, and also the magnitude of this force is proportional to the component of the velocity of this charge at right angle to that fixed direction. So the component of velocity perpendicular to this direction, so let us say if this angle is theta, then this force is proportional to the component v sine theta, that is perpendicular to this direction. Now this all peculiar nature can be described if we assign this peculiarity name called magnetic field. That is, this particular direction is having a quantity called as magnetic field, and in that sense if we define it like this, then this force can simply be written as the proportionality constant will be q and the cross product of v and this b quantity, the magnetic field quantity. So it is possible that we can describe this peculiar behavior, that is the force is proportional to how fast this charge is moving and it is always right angle to a particular direction, and also depends on the component of velocity which is right angle to the direction, that specific direction, can be explained clearly if we define a quantity called magnetic field. And we can write this force as F is equal to qv cross b. That is, this force is perpendicular to this velocity also, perpendicular to this magnetic field also, and its magnitude is proportional to the component of this velocity which is perpendicular to this b, that is v sine theta. So all of this can be explained if we define this as magnetic field, this quantity. There is some quantity called magnetic field vector b. So you see that the total force on the charge will be the electric field as well as the magnetic field, that is QE plus QV cross B, or if I take Q common, E plus V cross B. So you can clearly see that every point in space as far as electromagnetics is concerned is characterized by these two field quantities, the electric field and the magnetic field, and they give us the force on the charge. If the charge is moving, only then there will be this magnetic force, as well as there will be, of course, electric force if there is electric field in that at that point. So this equation is called Lorentz force equation. Now this equation has been found correct in all the experiments, so it is a law. That is, it cannot be derived from some other quantity. It is an experimentally validated equation. And now you might be wondering that we are all always talking about the velocity of the charge. Now this velocity of the charge is dependent on the frame of reference. That is, from where we are looking at the charge. In some frame, the charge can be found at moving with some velocity v1, and in some it might even be at rest. So you see that the total force on the charge can be either both the electric field as well as the magnetic force component. And in some reference frame, then when this v is 0, there will be only the electric field. So you see that this equation in itself is valid in all the reference frame. It is the quantity E, V or B which changes in these frames, different frames. So this equation is valid in all the frames, but it is the quantities which we should take care while putting the values in different frames. And we will see in our one of the lectures in future how the relativity of magnetic and electric field works. And in that case, we will see that in one frame there will be magnetic field as well as electric field. In other frame there will be only electric field, depending on the frame of reference. So this is the Lorentz force equation, and it is one of the basic equation which is experimentally verified and cannot be derived from any other basic law. So we will take it as a basic equation for solving so many other problems. So if you find that this lecture is helpful to you, then please share and subscribe our YouTube channel, and also join our Telegram group, whose link is given in the description of this video. Thank you.